dads are getting
What the
like I
heck?
think 7.5 each, and my siblings are getting whatever left. So
Yeah.
yeah.
So for me, I'm like,
2.5 I think.
I'm just gonna take the easy road out and just be like, divide it between
I think you can see that.
my sisters. I don't wanna talk about it.
I'm not talking about it. So where are we going from now? How's the next step?
Yeah, please. Oh my gosh.
I just do that.
Yeah.
I
Hey,
like don't even care.
I'm a fighter. I'm gonna fight. I'm fighting to the end. Damn, that's terrible. But yeah.
Damn, that's terrible.
I got 60 in the multiple choice though.
I'm gonna fight. I'm gonna fight.
How do we fix this? Like, what's he gonna say to be like,
It's like, so
here's how you can make a
you
point.
give us all like a slip. All right, so you need to withdraw from this course. It's the only solution.
I mean, I'm not failing, I just don't have a good grade.
I got 0 multiple choice. That is statistically impossible.
Oh God.
I guess what? I didn't get 0, but I got very close. I got very close. I got very close.
Really?
No, look. I got very close. Only got.
Also, I forgot to turn my.
I got very
projects.
close to
Like
0.
the rest
Oh
of
my
them.
gosh, like that makes no sense.
Yeah, right. So, and look at that.
You're supposed to have always been
The one guy. Where is he at? Where is he at? Smile, 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 please, smile. He gets a yes, yes. We are proud. A bit envious, but definitely proud of you.
How?
Yes, Hannah.
Go Tanner!
100.
Woo! Go Tanner!
Tanner, can you become a tutor? I'm not joking.
I could, but
There's no
the
upper
school
level
will
math
pay
class
me for
tutors.
it.
They would.
I
Oh,
get
they
the school pay me for it.
would
I
pay
mean,
you.
they won't.
Yeah.
I'm taking the class currently, so I can't tutor it until.
Well,
the school.
you could just be like, I'll tutor
I'll-
Calc 2, and then I secretly just get Calc 3 tutored.
Okay, right?
Could do it. Could do it. I need to reach out. Okay.
No, but it's
Got
like
Calc
uploaded
2
all the
waves.
courses.
Or I mean, if you can do Saturdays, we can root for everybody. Shoot, we'll
Yeah. Mac
throw you a
knows.
couple dollars.
Mac knows.
But what if I say, like, I need to review Calc 1 and Calc 2 stuff?
They're like, I'm
Or
fucking
my
here.
Calc 3 class.
I'm fucking here. You took out 2. You should know everything. That's basically what they say.
But I'm stupid.
The other day,
Well,
I
I'm gonna audit Diffie Q next semester.
audit.
Yeah, yeah. Audit means you can, if you already passed it, you can just retake it without a grade.
Oh, I love Diffie Q. I might do that. This is sit with Dr. S. and I need to throw
That's
I'm excited to
hopefully if
sit
I
in a
pass this.
actual math class with him. Because the way he teaches, like, Python is kind of, but,
He writes everything on the board.
How
He
many
makes his own notes, so I don't.
Guess
If
what?
I
I'm-
do 20% to both my
because
parents,
he
so
kind of
that's
makes
20, that's 40, and then the remaining
Like, I just
60,
Bro, let's
10%
just
each
switch
to
that. Bro,
my
can we
siblings.
So what was your grade? Did you pass? You passed, right? I'm sure you passed. Get out.
Like a 55.
Oh shit. How do you get a you got 100?
How?
Oh!
Tanner, we're very
Broke
proud
out
of you.
Yes, Tanner.
Just know that we're just not happy with you at the moment.
Yeah.
I feel it.
We're
I
just
feel
gonna
it.
stay upset, but we're proud.
Doesn't make sense.
Bro, what is the
Tanner got
multiple
100.
choice? How is that?
Nice, good job.
Down there, right?
Oh, I can't tell you the one.
I just say, just don't get discouraged.
Oh, wow.
I don't know if I was discouraged on last weekend.
Okay, I'm happy that the ones that did get wrong were the ones I know.
I'll say that. Don't get discouraged. Keep fighting until the final's over. That's all.
Okay. So, question 1 and 2 had the same information. We're talking about coordinates on a map. And it gave me the 2 partial derivatives. The first question was just find the critical points. So set each of those equal to 0. Solving this for 0, you land on y equals x squared. Solving this equal to 0, you land on x minus y squared equals 0. You can plug in x squared in for y. So you get x minus x to the fourth equals 0. I would say most people got to here. The only thing I saw was if we took cube roots, I saw a couple people put plus or minus. Don't forget, that's only if it's an even power root. An odd power root, you can
There is-
have a cube root of a negative.
Oh, wow, so it's only, okay,
It's
so,
just one.
that's right, it can't be negative, right?
So it's just one.
Orange can't find.
Then we would have 0,
Oh.
0, 1, 1.
One more time, hold on, I'm sorry, one more time with the cube root. So the cube root, it can't be negative because, oh, it can be negative, it can't be positive.
What I was saying was, if you have an even power root, like square root or fourth root,
Mhm.
if I say like some number squared equals 4, and you take the square root of both sides, you get plus or minus 2.
Right.
You've got some number to the third, and you take the cube root of both sides,
Two.
it's just 2.
Two.
You don't get a plus or minus.
Look at here, you learn something every day.
Alright, so number 2, in words, it's just asking for a directional derivative. It's saying if you head in the direction of, it says north, 45 degrees east, but really it's just saying in the direction of this vector. So if you head in the direction of that vector, will the hiker be walking uphill or downhill? You want to do your gradient vector dotted with the direction vector. You get a positive number walking uphill. You get a negative number walking downhill. I had a couple people have this line and then write a decimal approximation for this, like we just typed into a calculator. Sure, fine. I understand what you're saying. So you take the dot product, and all you're investigating is just positive and negative. Questions on 2?
Okay.
So we had to write all of the, like, equations. We couldn't have just said, oh, the hiker's walking down.
And this says explain your reasoning. I'm looking for the math. The final answer of uphill or downhill is, if you want me to take a second look at it after.
Is it uphill or downhill?
Say again?
Is it downhill?
Yes.
Hey, okay, whatever.
Alright, number 3 was pretty straightforward. We saw this, I think, on a couple of the practice tests. It's just, we're looking at the table. I'm looking to see where the partial derivative with respect to x and the partial derivative with respect to y are both equal to 0. That's at 2, -1. I did see a lot of issues with the discriminant. I feel like we weren't confident in how this works.
Right.
When you plug this in and you get a number, some people were saying, oh, concave up, so minimum. No. If the discriminant is positive, it just means you have an extremum, a max or minimum. You then go check your second partials and see if those are positive or negative. Because your second partials are both negative, then you can think about concavity, so you have a maximum. Like I said, but I think everyone was doing a discriminant. We just were misusing that and saying that means it's a minimum.
Now, question: if one of your say if your gx of x is negative and your gy of y is positive, then
That's a good question. So what would end up happening there is a positive times a negative is a negative.
it's negative.
Minus something, negative, so sine.
Oh, okay.
Or write an equation of the plane tangent to this surface at the point 3, 1. I think for the most part this is pretty good. Maybe an algebra mistake or two, but z minus the z coordinate, partial times x minus 3 plus partial y times y minus 1. Solve that for z. And then the statement you can make is this surface behaves like this plane near the point 3, 1. So if I plug in 2.9, 1.3, you get roughly 6.9 inch. Alright, 5. So consider this surface define on the region, and it gave me an image of the region. I can kind of zoom in for us. It says that all of the candidates are already found and labeled. So you only have to look for 1, 2 points. There's not even an interior point. This, just using geometry, is -2, -2. This point is along, what is this line here? Keep going. Is this x or y equals?
Your x is -2. I'm not sure what the y is.
I saw a couple of people putting y equals -2. This is x equals -2.
Yeah.
So what you would do is plug in -2 for x, and you get something in terms of only y. The most common mistake from here was we were setting this equation equal to 0. You want to find where the derivative equals 0. You want the critical point.
Okay. I'm gonna have to watch this
So
video.
you do get plus or minus here, but just kind of looking at the region itself, I'm not interested in a positive y coordinate. So I only want the negative region. So getting this point was probably 4 or 5-ish points. This was maybe another 2 points. And then from there, it was just down to making a table. And hopefully we didn't do this manually. We had Desmos, we typed in all the values. We just found the largest z value, the smallest z value. That's your absolute max, your absolute minimum.
All solutions. Like,
I was gonna say, how many points was each question on like the first?
10.
It was half of those.
are you gonna upload these or?
I think it's multiple choice. I think it's multiple choice.
Alright, multiple choice. Given this function satisfies the partial differential equation, your second partial with respect to y, so that's partial y, minus 2 times, careful, help me out with the order there for the second one. What order do I take that in?
Second one, you take your derivative of x first, then your derivative of y. Ooh,
That notation is right to left.
right there, dude. That's right. You just
Y, then
then x.
So I took my partial derivative with respect to y. Then I took the partial derivative with respect to y again. And over here, I took the partial derivative with respect to y, then with respect to x. The question is just saying when you grab this equation minus 2 times this equation, clean it up, you get this. It's saying ax, by. Adding those 2 values together, you get 2.
There you go. That's what's up. I didn't get. I was far from being anything.
I think the, kind of just glancing over the scratch work, what I was seeing was, for that second piece, I saw a lot of x then x.
I think we just got it. I got it.
So it should be y then x.
Right. I think what happened there is one of the ones on the practice test similar had x then x. We were just getting into routines. But that notation is saying y then x. Questions on one?
Oh, I like cross out the X's and add them together as fancy money on here.
Okay.
At first I thought it
A vector value function is given by that thing, which the following is the parametric equation of the line tangent at t equals 0. So I want a line, I need a point, I need a direction vector. The point is when you plug in 0, we can't be forgetting things like this. E to the 0 is 1, minus 6 should be -5. So I know the point should be -5.
Something, yeah.
You plug in a 0, you've got ln of 2 times the original 4 up front. Plugging in 0 into the last one, you got square root of 1, so just 6. Then you take your derivative. These are all Calc 1 derivatives. Kind of glancing through some scratch work, we got to review some Calc 1 derivatives. We have to know how to do this stuff. This is a chain rule. Derivative of ln of something is 1 over the something. Derivative of square root of something is 1 over 2 root something. The only interesting thing though is we would land on 4 ln of 2, and skimming through the answer choices, I don't see 4 ln of 2 anywhere. What is another way of saying 4 ln of 2? You could say ln of 2 to the 4th, or ln of 16. Say we totally forgot that. If you plug this in a calculator and got a decimal approximation, and then you typed in 4 ln of 2, your decimal would have been the same. Sorry.
So hold on, that 4 ln of 2 is that you're saying that's okay, 4 ln of 2 equals ln of 16.
And I'm not saying you had to even know that. You could have gone through the other answer choices and said, well, I'm definitely between, B through D, and the slope isn't 3 over 2, and just by process of elimination, you would have stumbled on, oh, okay, that's right. There's some sort of reword. Alright, I think this one was, actually I've got the stats for the multiple choice. So it says the equation of the plane is, the equation of the surface is given by that. X minus y equals 0. We should know by now that is a plane. No Desmos, no graphing.
X equals y.
So the question is, which one of these equations represents a plane? Theta equals something is in my notes as a plane. R equals pi over 4, going out a radius of pi over 4, it's a cylinder. Phi equals pi over 3 is a half cone. Z equals pi over 3 is a plane, so I'm already kind of between these two, and that's just a sphere. Pondering it for a second, Z is just Z. So that is parallel to the XY plane. Well, hang on, if this is a rectangular coordinate in addition to a cylindrical coordinate, then if it was that plane, it should just be Z equals 0. It's not. So it'd have to be theta equals pi over 4. There are substitutions you could have made. You could have grabbed your arc tangent and solved. I think using the other answer choices would have been the best way here.
The way I didn't get it right, but I did get the pi over 4. I said like the direction of it, I was like, well, x equals y is like a diagonal line, and pi over 4 is also a diagonal line.
I mean, that's exactly it.
Okay.
If you think about the XY plane, the angle is pi over 4, and the XY plane, that is the line, y equals x.
Okay. I just forgot.
I think 4 was quote unquote the hardest one, but not necessarily the most missed. So I was happy about this one. So you've got a parametric equation. It's describing a fly moving through the room. And the question is just to ask yourself which one of the following is true about this fly. Traveling away from the XY plane, not sure how to deal with that yet. Same thing with traveling towards the XY plane. If the particle is at rest, what does that mean about my velocity vector?
All 0.
All 0. If the particle is at the origin, what am I looking for?
Your position.
That the position is 0, 0, 0. And this is an interesting one. If the particle is traveling parallel to the XY plane, what does that mean?
Is that right? Or is it, no, it's perpendicular to it?
If I'm traveling parallel to the XY plane, then my Z prime
Oh, it's on.
is 0.
Fixed, right? Oh, 0.
So if you had a velocity vector that was something, something, 0, you're traveling parallel to the XY plane. So after taking my derivatives, I noticed that Z prime of 0 is 3, which means this fly is traveling upwards. So I'm only between A and E now. The only question is, am I traveling upwards towards the plane or traveling upwards away from the plane? And how would I make that distinction? You need to know where you are. So you need the z coordinate at that time. You've got the z coordinate is negative, and traveling up, you're heading towards the plane. If you had a positive z coordinate, then you're traveling away from it. Questions on 4?
Yeah, I did like the velocity vector, and then I did the velocity 0, and that was the same thing.
Well, that's just like you moving up. But are you moving up away from the plane? Or up?
I mean, I just said because it's positive, it's above the axis, therefore it's moving towards the x. I didn't.
But I'm below the x. If you're above
I
it,
just not like the velocity's moving up, and so I just meant going towards, so
towards what?
the
Yeah,
x.
it is moving up.
But I'm below it, heading up.
Yeah, it's
moving
the
towards
velocity
the origin.
up because it's positive. Or is that not the way?
So careful, the fly is coming. The velocity is positive.
Yeah.
If the velocity is going up, you're saying the velocity is increasing.
Yeah,
The
the
particle is
velocity-
accelerating.
Okay, I guess I meant like the velocity is positive, therefore it's going towards the xy plane. I don't know, that's what I thought.
But careful, if you are above the xy plane and have a positive velocity, you'd be moving away. So you have to look at both the z coordinate and its derivative.
Let's see. Coordinate and derivative.
Which of the following is the normal vector plane tangent to the surface? Kind of the same idea. If you want to make a tangent plane, this time it's really just asking, do you remember stuff from unit 1? Write it in the form something x, something y, something z, just grab that vector. But then I look over the answer choices and I go, that's not an answer choice. Ah, I see. They just scaled that vector by -1.
Negative one, yeah.
6 was pretty good. The only thing is potentially fell for, we have to pay attention to what quadrant we're in. So I've got arc tangent of -1, which gives me quadrants 2 and 4. So that's going to be either 3 pi over 4 or 7 pi over 4. Well, if my radius is 1, then I've got 3 pi over 4 and I don't see a 7 pi over 4. But then I remember, what's another way of saying 7 pi over 4? Negative pi over 4.
Yeah.
Questions? So which of the following has the domain given by the region shown? So I've got some sort of circle. I've got everything shaded outside the circle. It does not include the boundary. So I already know kind of my domain rules. It's gonna be I'm thinking like a natural law. Because if it was square root, it would be greater than or equal to. If you end up solving this one, you end up getting, it's everything shaded inside the circle. So just giving this one another shot, everything inside has to be greater than 0, r has to be greater than the square root of 5. So if the radius is more than the square root of 5, it's everything outside of the circle.
Can I just check because like ours is cylinder, so it kind of makes like an R, a circle shape.
Say it one more time.
You also think like ours is cylinder, so that's why it's like.
It was pretty good. If y is fixed and x varies, it's just a word salad way of saying partial derivative with respect to x. You'd have to rewrite that as yx to the -2nd power, do some power rule, plug it in. That one was pretty good. That was a tough one. So if I put a point, we're talking about the points 0, -1, two, 2, and -2, 0. The first one it's saying if you're at the point 0, -1, and heading in the y direction, so heading straight up, are these level curves increasing or decreasing? Increasing. I think maybe we got thrown off by some negatives. Because we were seeing like a 2 and then a 0, so we're thinking decreasing, but hang on, going from -2 to 0, I'm increasing. So the first one is true.
That's a negative.
The second one saying if you're at the point 2, 2, traveling in the direction of V, which is 1, 1, if you travel along that line, well, hang on, I'm on the same level curve. I'm not increasing or I'm literally walking along the same Z coordinate the entire time. So the direction vector equals 0. That is true. The third one says if you're at the point -2, 0, heading towards the positive x-axis, then we are walking downhill, and that is true. 4, 2, 0. So actually all three are true.
How do we know that the point -2, 0 is going that way?
So kind of our definition of partials is saying you're always heading in the direction of the positive axis. So even for the y, you're only going to head up for y. You're only going to head to the right for x.
And that's for all partials.
Say again? For all partials. Yep. Even partial of z, saying you're heading in the direction of the z axis.
And isn't derivatives in general, since it's a change, the positive change, and if you're not changing, then you're 0. So you're always pretty much moving.
It's as the variable that you're taking the derivative with respect to increases. So you can, in Calc 1, we always read left to right because z is increasing in that direction. Tip was pretty good. We just grab our reference sheet, rho, sine phi, cosine theta. Just reduce this. Again, maybe it's been a while since we've seen radicals. I forgot how to reduce some of this stuff, like square root of 12. You could have typed it in a calculator, got a decimal approximation, and then just could have seen which one of the answer choices corresponded with that. So yes, I'm going to post the solutions to Blackboard. So let me ask you guys this. How are we gonna make this up somehow?
No.
So I don't,
Yeah,
I never believe in retakes because it always happens that I give a retake and the scores are the same. However, when I gave a retake for exam 1, everyone kind of rocked it. But we can't do this habit of we take an exam and then we actually start studying and then get a real
Just gotta
score.
lock in.
I studied till 2.
We were studying like all night the night before, and like we kind of talked about it as a group, and we kind of felt like we did all the practice exams, we felt strong on them, and then it was like there would be problems where like normally you would have given us a graph for that type of question, and then you didn't this time, and it totally like mentally blocked us, and we're like, oh, we knew the process when we were given these things pretty easy, but when we were given something else, we were really kind of stuck.
So after seeing the solutions, what are we?
After seeing the
I
solutions,
feel
it makes
I think when I
sense.
took the test, I was just tired and I wasn't focusing right.
I
So
feel
was
like, for me at least, I do the practice exams, and I'm like, okay, I understand this. And then the practice exams and like those methods and techniques are on my cheat sheet. And then I take this, and I'm like, I don't know any of this. And even after going over the solutions, I'm like, yeah, I still don't know any of this.
Yeah, but that's
I
I feel like the practice exams are easier than the actual exam, like
Yeah.
too much.
And like, I guess for me, like for number one, I just didn't understand the wording of the question. I thought A was as an A was B, so I literally just crossed out A, the X and Y from both. I'm like 42. So I was like, no, I got confused on that.
So we probably, we
That is
don't,
also on
we can't afford to miss another day of class, so maybe I'll post something, but we'll do another attempt next something, Friday. But like I said, like, we can't be every test, like, okay, now we're gonna study.
Do we have, would it be another exam and then the final, or just the final?
Exam 3.
Same 3, then 5, yeah. I just wanna see.
Yeah.
I just want.
It's like 3.5 weeks, what
Would it
month?
be like the concepts that you missed or something, those are the things that you redo?
What about
Correct, like
corrections?
test the proficiency of like what we're actually missing.
Shit, I missed everything.
The problem is everyone missed
Oh, the
it.
voting gates.
Yeah.
That there wasn't such thing like everyone missed it.
That's basically the whole test, when, as far as group wise.
There were some questions that, you know, half the class got, and there were other questions that the other half got. All right, you guys ready to start unit 3?
Let's go.
Is it
Move
integration?
forward.
Say it.
Is it integration?
Integration, yeah. Move forward and
Here we go. It's not good, so it's.
We'll
This is gonna be.
we'll shed a quick tear for test 2 and move on.
One more time.
So we'll shed a quick tear for test 2 and move on. I'm not giving up.
Okay. Calc 1, we were given some sort of function, some sort of curve, and we were asked to find the area under that curve. So now in Calc 3, we're given a surface, we want the volume under a surface. And as I would not be able to draw this on the board. Got a nice graph. So we've got some general surface, f of x comma y, over the region in the xy plane. So we're no longer integrating from A to B, but we're integrating from A to B along the x-axis, and then from some C to D along the y-axis. So we're always going to be integrating over a region. And right now it seems pretty straightforward, like, oh, R is just a region in the xy plane. This idea of identifying the region is kind of one of the big heavy lifting things we have to do in the unit. Turns out the actual integration part isn't hard at all. It's only finding the region. So in Calc 1, we have Riemann sums. So the way that we can approximate the area under a curve, we would just make a series of rectangles and just start adding in more and more and more rectangles. And we saw that the limit of the sum of the areas of the rectangles would just have some limiting value to what the true area under the curve is. For Calc 3, we're not doing rectangles under a curve, but prisms under some sort of surface. So we're going to find the volume of these prisms, add all of the volumes together, and again, if we take the limit as the lengths and the widths of these rectangles went to 0, that would give us the exact volume under the surface. And here, this is just showing us, just like Calc 1, if you take the function's height times change in x, but now for Calc 3, I want the volume. So length times width times height. If you added all that together, you just had an infinite number of rectangles, This idea is what we're gonna see in all of Unit 3. So we'll call this a quote-unquote double integral. So when we're talking about volumes under surfaces, we're talking about a double integral. I'm integrating from A to B in the x direction. Notice there's a kind of inner piece. A to B in the x direction. And then in the y direction, the outermost piece from C to D.
So, really it's like, kind of like the f of x, y idea that you did one first and then the other first, or not?
Let me make sure I understand this.
You know, like the partial derivative of x over x, or something like that. Like,
Yes,
yeah.
you're gonna start with the innermost piece, you're gonna do x and stuff,
Uh-huh,
and then y's.
okay.
Alright, let's first do one Riemann sum. But let's first review some Calc 1. Let's do a Calc 1 example first. So this is a question that my Calc 1 students are seeing right now. Approximate this definite integral, but they don't know how to do antiderivatives or fundamental theorem calculus yet. So right now they're only seeing using a left Riemann sum, which don't forget it just means draw a series of rectangles, combine the areas, and approximate the area. With n equals 4, that's the number of rectangles. So visually, I've got x squared plus 1 and I want the area under this graph from 0 to 2. This is just a rough sketch, it's not perfect. But drawing a series of rectangles, I want 4 rectangles. And I'm going to draw the rectangles in such a way where the left corners touch the curve. The prompt asked me to do a left sum. If it asked me to do a right-hand sum, then I would just draw the rectangles where the right corners touch. To figure out the width of each rectangle, your delta x, or the width of each rectangle, is equal to b minus a over n. B is 2, A is 0, N is the number of rectangles. The prompt told me to use 4 rectangles. So now to stay organized, I'm going to put everything in a table. Start off with an x value of 0 and just increase by 0.5 each time for x. So 0, 0.5, 1, 1.5, and then 2. And now to find the y coordinates, that's just gonna be f of 0, whatever you get when you plug in 0. When you plug in, and I agree, when you plug in 0.5, let's just grab it. Say again?
Oh, 5/4.
I can't.
5/4.
So 1.25.
Then it's 2.
Yep.
Then it's 13/4.
Which is
3.25. And then it's 5.
And then just so we don't have to draw rectangles every time, this is what I show my Calc 1 students. On the table, you can sketch a series of rectangles. These are just arbitrary rectangles. The heights are meaningless. It's just to help you kind of visualize what's happening in the real picture. And when it asks for a left-hand sum, you can just mark heavy the left corners. And now the area is going to be approximately equal to, you agree that the width of this rectangle is 0.5? Because it's 0.5 minus 0? Times the height, and I marked heavy the left-hand corner for a reason, to show me that's the y coordinate that you're going to use. The height is 1. Plus, I'll give you guys 30 seconds to do the rest of them just to make sure we can do this. So then the next one, the width should be 1 minus 0.5 with a height of 1.25. Then I've got 1.5 minus 1 times 2 plus 2 minus 1.5 times 3.25. Someone with a calculator, what do we need? You get 4. So again, in this process here, I don't know how to do antiderivatives yet. So we gotta start somewhere. So we can draw a series of rectangles. That's what we call a Riemann sum. We're gonna do the same thing for Calc 3. I don't know how to do these dumb line integrals yet. So if we wanted to approximate
Yeah, 3.75 and then 1.
instead of 4,
Yeah, 3.75.
So now this is our Calc 3 version. Approximate this double integral, we'll call it. For this function, x plus y, using an upper right Riemann sum with n equals 2 and m equals 2. So a couple things. Looking at this first, read inside then outside. In the x direction, you're sweeping from 0 to 2. Outermost pieces. In the y direction, you're sweeping from 3 to 5. First thing I would do is just sketch the region in the xy plane. So in the x direction, we're going from 0 to 2. And in the y direction, we're sweeping from 3 to 5. So first thing I want to establish, that is the region that we're integrating over. What does that mean? I'm doing my bird's eye view looking down, and I've got this surface that's hovering over the xy plane. Our goal is to find the volume under that surface. And again, you spend the most time just interested in the region. Turns out the double integral itself that we're going to learn in a couple classes really isn't that hard. It's just understanding the region. So it says approximate using a Riemann sum with n equals 2. Same thing from Calc 1. It's the number of subdivisions along the x-axis. And m equals 2 is the number of subdivisions, but now just in the y-axis. So you can have maybe only 2 subdivisions in x, but maybe 4 in y. Why we would do that, not sure. But n and m just represent the number of subdivisions along the x and y axis. So this one doesn't really call for it. But say we needed to know how to find the width of each subdivision. Then your delta x is still b minus a over n. That doesn't change. But now a new piece for us, delta y is going to equal what?
D minus C
Okay, over.
over N after M.
So same flavor, just now we're going in the y-axis. It told me in the prompt to use an upper right Riemann sum. That language is a little new for us, and now we might be able to tell why. These are going to be little prisms or little blocks pointing out of the bowl. Well, which height do you want to use? Do you want to use the height here, 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 or here? So when it says upper right, it's saying for this prism, use this point as the z-coordinate to find the volume. Use this z-coordinate for this prism. So for Calc 1, all we had to decide was, do you want the left corner to touch, or do you want the right corner?
How do we get that cross section?
How did I get this one? So it told me n equals 2. That's the number of subdivisions you have along x.
So I really basically just like make it, so if the n equals 3 and m equals 3, it would be like a 9, 3 by 3 then?
If both n and m are 3, it's 3 by 3. Second,
X is kind of made up the wrong picture.
you're just making a little grid.
And what did the dots do? Where is it?
So the prompt told me to use an upper right cell.
Oh, so,
So the heights that are popping out of the board of this prism, we're gonna use this Z coordinate.
so are we just gonna, since it's upper right, if let's say if it was like middle, which one would we use?
Oh, that's a good question. So in Calc 1, you also could have had my midpoints. Where the center of the rectangle touches. You can have that in Calc 3 too. It would just be here. So you would kind of just partition this again to find the midpoint for both of these.
Oh, so it would be right in the center of each of the little squares. Okay. And if it's upper left or down left, it'll tell you exactly.
It'll tell you which one to
Which
use.
one's the three right? Like if it's like middle, left, right.
So you still have squares. No matter how many squares you have, you're gonna have an upper left and upper right. So I'm gonna go ahead and just keep this organized in a table. So if I want to figure out the function's values, you can create a quick table and find all of them. We only really need these four. So we can either grab a calculator or grab Desmos. What is f of 1 comma 4? I think I made it this easy for a reason. It's just x plus y. F of 1 comma 4 is 5. F of 1 comma 5 is 6. 2 comma 4. 6. 2, 7. So the function is f of x, y equals x plus y.
Oh, that's.
Say again, did I make a mistake?
I was saying, yeah, plug in X and Y coordinates.
All right, we're ready for our approximation now. Again, these are prisms that are popping out of the board. The area, excuse me, the volume of a prism, length times width times height. So for this prism, and I'll put it in a different color just so we can see it down there. The width is 1 minus 0. The length is 4 minus 3 times the height. And what is the height that this prism pops out?
Five.
5. And I agree, it's x plus y. When you go to 1, 4, it's x plus y, or if you look at the table, you have 5. So this point is saying the z coordinate of the function. Well, f of x comma y is x plus y. So if I take this point, you agree that's 1 comma 4. You just want f of 1 comma 4.
Oh, okay.
Plus, I think I realized that all of them have 1 and 1 in either direction. So 1 times 1 times, if I go 1 up, that'll be 6. Plus 1 times 1 times 6. Plus 1 times 1 times 7. So I get 5 plus 6 plus 6 plus 7 is what?
6, 11, that's 7, 17.
Wait, I'm sorry, could you get the 1 times 1 times 6 and then the 1 times 1 times 6?
Yeah, so maybe if I remember these. So I did 1,
24.
2, 3, 4. So 1, 2, 3, 4. So this first prism, length,
7.
width, height. And this dot is the z coordinate. 1, 4 is 5. So 1 times 1 times 5.
Can you like draw arrows for like length of? You know,
Say one more time.
can you draw like arrows saying like,
Like this?
yeah.
So basically,
I noticed that all of them have length and width in 1. So 1 times 1 times z. 1 times 1 times z.
so in this case, you're like, that like 1 times 1 is like your step value, kind of?
The 1 is the step value. You're just jumping 1, 1, 1.
Okay, and the first one we got 1 minus 0. What is that?
It's just showing the width of the rectangle.
Okay.
So why am I showing 1 minus 0? These won't all necessarily always have the same uniform step. You could make kind of ugly rectangles to fill a region.
Okay.
So, like, didn't we just look at the little chart we made this entire time?
Say it.
Can we just look at the little chart for this, like, this entire time?
I'm not saying no, but you do what?
Where like the 5, 6, 6, 7, like, is it that little square, is that the answer? Or like, how does the chart and the graph?
The chart was just to help me organize what the z coordinates are at these points. So my dots were 1, 4, 1, 5, 2, 4, 2, 5. It's just to help me see the z coordinates at those points.
How do you do number 1? I'm confused.
Number 1, you're saying
Why would you do the first block?
the first square?
Yeah.
Well, I need the volume of the prism.
Uh-huh.
And the height of the prism is this z coordinate, which is 1, 4,
1, 4.
which does come from
This is
here.
5. Right.
Every block that you see here has a volume that we added to it.
Oh, okay.
1, 4.
I almost need like Legos or something to pop out of the wood.
And 2, 4, 2.
So if it was an upper left triangle, would we use 4, 5, 5, and 6?
You would use 0, 5, 1, 5, 0, 4, 1, 4.
Since we're using the right, upper right, it would be 1, 5. Since we're using the upper right, it would be 1, 5.
The upper right would be, yes, 1, 5, 2, 5,
1, 5, that'd be 6. Then the 1, 5, you get a z value of 6.
1, 5, you get a z value of 6. This one says find the exact value of this thing. So this is just making sure that we understand double integrals themselves. that we understand geometry, and specifically, we understand the region that we're talking about. So for right now, we're gonna remember that this is a 5, and I'm gonna erase it and leave it blank. Just to exercise only the region that we're interested in. So it says find the exact value. This is gonna tell me the volume under some sort of surface. Again, do not care what the actual surface is for right now. This is saying you're gonna open up and sweep from 1 to 2 in the x-axis, and from 0 to 7 in the y-axis. So again, I'm looking down in the XY plane, and I have the volume under this surface over this region. And you can actually put any surface that you want here. You can have it dip down, you can have it be below the XY plane, you can have it be flat. We already had the surface 5, which remind me, if f of x comma y equals just 5, what does that look like?
A vector, a line.
F of x comma y is the same thing as saying z.
So z equals 5 is a plane.
So this is a plane parallel to the xy plane. So what kind of volume would I be finding if this is rectangular and I have something flat up top? Still just another prism. Prism.
Yeah.
It's just, I've got another prism. So this is saying find the exact value, no approximation, and now I understand why. It's just some nice geometry. I've got a prism with a length, a width, and a height. So take 2 seconds, find the point.
Actually, this is the right class on this. I'll put them back separate here. Yeah.
All right, so let me just write this up here. So I have a prism that has a width of 2, a height of,
This is 1.
oh, so thank you. Didn't make it in translation. So a width of 1, a height of 7, sorry, excuse me, height of 5, on length 7. I get 35. Let's talk about sketching this in Desmond. I think being able to see exactly what this double angle is just how it's settled out. So I've got z equals 5. And now let's go ahead and in the next line, just say sketch this function between x is 1 and x is 2, and sketch y between 0 and 7. All right. Alright, we always had Desmos do this. I'm kind of confused. Why can't I get this to work?
Maybe because there's no X. Like, F, X, Y is just there. Like, there's no X or Y.
Wait, so it has to be in terms of x and n. So let's say z equals 5 with 30. Okay, this will work. So this is the rectangular region that we're interested in. Maybe I can change this just a bit. So this is the rectangular region that I'm interested in if I'm looking in the XY plane. But now to draw the volume underneath, I want all z to be less than or equal to the function, which is 5. Sketch. Alright, this is not cooperating the way I thought it would. Oh yeah, you can do z is less than or equal to 5 here. But that's going down forever. I want to be above the XY plane. There we go. By the way, when doing these drawings in Desmos, it might pause for a second and kind of think, and then start to put a volume there. So don't think because it doesn't auto-populate immediately it's volume. So now just erasing the surface, this is the volume that we're interested in. And we're going to see this with complex things. The region will not always be rectangular. And that's really why this unit exists in the first place. Because if it was this simple, it actually wouldn't be too bad. But you can have like a little teardrop shaped region, or have a circular region, where you can do all of our double intervals there.
Okay.
The last thing I want to talk about would just be this one. All of these, we want to use geometry to evaluate these intervals. Here, my z equals 4, parallel to the xy plane, so I understand that I have a prism. What on earth does this surface look like?
A half circle.
Say again?
Half circle.
Yeesh, but we're so close. It's a half what? half a sphere.
Spear,
Semi-sphere.
spear. Right, spear.
So we wanna just mark on our sheet that the volume of a sphere is 4/3 pi r cubed. But this is a semi-sphere, so don't forget you wanna divide by 2.
Two. Good. Phew, this is a lot.
Alright, so next time I'm gonna kind of count out, see how many classes we have until the end of the semester. I'll bring in a new course topics list for the third unit. Look out for an email on Blackboard talking about when we can meet to do another intake for exam 2. And I will see everyone on Wednesday.